Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. Today, we'll be looking at another problem set from the LeetCode series, more specifically the one called the longest continuous increasing sequence, and that'll be an array type problem. So let's look into it and then do first a bit of a simplistic approach. So let us actually go to the description and ignore that you just saw the solution. So here, okay, what's going on? We have some kind of array as our input that's nums. Fantastic. And basically, as is described over here, we want it to continuously be increasing. So as soon as it hits, for example, a number that's lower than, and I'm going to use a keyword that's going to be helpful, we reset, let's say, our count, because so far this has been the longest array, hence our answer 3. The only other longest we have where we're increasing and not even staying still, because that also doesn't count as continuous as per the problem set. Then yeah, the best we could do here is 3, and that's what we're returning, so we're just returning an integer. And one, I guess what I like to call the meh approach, it's actually not bad at all. It gives you the same sort of metrics when you run it, but this is how I was solving it the first time, and then starting to realize that there's this sort of broader concept called the sliding window. So let me make sure to get to that later. But first, let's just see the intuition from the broader problem. So here, what do we got? Basically, I like looking and trying to get any, how would you call it? Anything that is a sort of an obvious return statement, so that you don't waste time going through anything, even though in this case it just means, you know, your for loop in here would be very short. But basically, you know, if it's empty or if it's just of size 1, then you know what you're going to be returning. But this is sort of more of the meat. So once we're inside, really, what was my thinking over here? Well, we've got this sort of array situation going on, and I want to know when I may be starting to not increase. So I'm thinking, you know, let me start somewhere over here, and that's sort of what I'm calling the left index, and also have sort of a second one also starting at the same location, and I'm going to go ahead and call that the right index. And basically, as I'm going through, I'm saying I'm going to need to look at 2 things. You know, did we mess up and we're no longer increasing in a continuous manner? And that's sort of what we have over here. Let's see. So the I minus 1 is the left-hand side, right? As you're looping through, and by the way, we're starting by 1 because we already have the 0th taken care of. So now if we're going to start comparing 2 elements, we want to make sure we're at the next one. So you start at your 1, and so this is left side, this is the right side. And ideally, yeah, if you're increasing, this is fantastic. You're good to go. So what I do then is say, all right, I'm good to go, therefore 2 is a good one. I'm going to go ahead and increase my my right index, what I'm calling. I just did air quotation with my hands. And basically I was thinking, well, I guess I better make sure I'm kind of remembering the length, or rather remembering in the first place by having a variable for it, but incrementing, whenever I'm in a good path, right? I'm now increasing. I didn't hit some kind of wall, which is going to happen over here. So that's my little increase there, and then otherwise, this is sort of where you do hit this wall is we're in this world. So there I say, all right, therefore I need to go back to saying this is my left index and same position, this is my right index, and we're gonna start again, right? And so my idea was, let me make sure to be at least comparing what was the longest thing I got to, because this one is fine, right? You've got your 3 that happened early on, and this one is shorter, so no problemo. But right here, this is where it might be trickier, and I'm adding this bit. It's maybe you could have had the opposite, right? 3, 7, and actually it's at the end that you're truly getting that 3. So you'd have only saved 2 for your total length, and you wouldn't know about this 3, so this is why I'm adding this. But it's an overkill, really, and we're about to look at a much better solution, but also this broader concept that I was talking about, the sliding window. So let me write it in big lettering, sliding window, even better. So we can move on. All right, so that gets at this part, but at least hopefully that covered, the idea, the reasoning behind this. So one thing we could do is, actually I'll stay here and go to the solution so that you sort of see where I want to give credit, of course, to the right people here. So this is sort of where this is coming from. And then I kind of tried to rewrite it myself. So not that there's a need for it, but basically what one can think about is also, and we could actually get rid of this on this side, is instead of sort of all those little tricks and pieces and me trying to remember when I need to, save the length of things, is thinking actually. And I love this concept of the anchor. Literally, think of a little. I'm gonna do my best at drawing an anchor. Think of that happening. Literally, you have this array, and you're saying, I'm gonna use this anchor, basically index, right, as my positioning thing. And then I'm going to start looping, and that's sort of the I that's getting incremented. So if we have no problem and everything is going great, i.e. we're going up, then your I is going to continuously be going up, and say maybe it messes up here. So if it messes up there, basically already all the way, and let's do it maybe in green, all the way here, is great. And actually, what you realize is by keeping this anchor over here, and which is kind of the equivalent of the left index I was talking about earlier, but this is just a lot cleaner. So there, what's happening is you kind of already know you've got your I being basically your, right index from earlier, and but you're not assigning anything. That's already what's happening in the for loop, and then you minus from it your anchor, because that's sort of your golden index that's keeping you literally grounded, anchored. And you do a little +1 because of the whole array indexing, etc. So that actually magically kind of already gives you the length thing. And so what you end up doing basically is remembering to each time do a little max. So just like before, we do want to save some kind of thing that you're going to return at the end. Here they're calling and so let me move to, for example, this one. I'm calling it more of a of the longest sequence. To me, that makes sense as sort of the output. I'm still doing my little check part over here, but that varies, and you can ignore it if you'd like to. And you've got your little anchor, and basically, it's the reverse of what I was doing earlier, where it makes more sense to say, when do I mess up? i.e., my left element in my array, which is sort of back to that whole thing. One would be where we mess up and we haven't been increasing. That's really where it matters, or when it was equal, like we saw the 2, 2, 2s. Yeah, so basically when that happens, you say, all right, little anchor, the blue thing I drew earlier, now you're going to be set at this new position, and otherwise I'm going to keep on moving my little eye. And that gives you automatically the solution. And over time, you're always keeping track of anyways, what was there any longer sort of series of elements that you've seen one after the other. So sort of what we've seen earlier, sometimes maybe you've already had 4 here, and then towards the end you only had 2 that were increasing. Then, it would have been captured over here, and basically, this would have been changed, this longest, to 4 when you were still here, and then eventually when you got to this part, it does yet another comparison, but basically the longest sequence would still be 4 as the highest, so you're gonna not look at the 2. And that's pretty much it. So I should have actually gone here, and that's for me I would say the better solution, both from the solution part or the one I was adding for you all. I hope this was helpful. As usual, please feel free to add any comments of things you'd like covered, or be it in this series or other ones, and feel free to subscribe. Thank you very much.